Good morning, students. Today we discuss about limitations of octet rule. So, limitations of octet rule. Limitations of octet rule. So, what is octet rule? So, according to octet rule, if an element having 8 electrons or ns to np6 configuration in the outermost, that is considered as stable electronic configuration or inert gas configuration. So, here an element ns to np6 or 8 electrons in the outermost. So, therefore, but some elements are having less than or more than molecule or outermost, they are having more than or less than. So, but they are stable molecules. So that is the limitations of the octet rule. Actually, octet rule is if an element having 8 electrons by the bond formation, after bond formation or before bond formation, whatever it may be, if it has 8 electrons in the outermost, that is considered as stable. But this is called octet rule, but we are discussing about limitations. So we are crossing the octet rule. After crossing octet rule, what happened? We will discuss about the molecules which are having more than or less than. We will discuss. After I will give this for this. 3 types of molecules are observed here. First one, incomplete octet. Incomplete octet. Incomplete octet. Incomplete octet. Or after that, super octet. Super octet or expanded octet. After that, odd number octet. So for this, here I will give an example. These are also called as electron deficient. These are also called as electron deficient molecules. So electron deficient molecules, what are electron deficient, what are super octet, what are expanded, or what are odd numbers? Just I will give the example, after that we will discuss about. So BeCl2. We will take BeCl2 structure. Here, this is central atom. So chlorine, so okay, for chlorine it has 2 electrons and chlorine having 7 electrons. So here, this is chlorine. Okay. So this is Lewis dot structure. I am already given that one. So when observing chlorine, okay, it has 8 electrons and it has other chlorine also having 8 electrons. But in case of beryllium, only 2 electrons. It is not completed octet rule. It is incomplete octet rule. Incomplete octet rule. Therefore, BeCl2, beryllium chloride is an example for electron deficient molecule. Super octet, I will give an example for this. Super octet means expanded octet. So it is less than octet, 8 electrons. Beryllium having less than 8 electrons. But super octet, for example, I will take one best example for this. Not for this, for octet rule. So methane we are taking best example. So carbon having 4 electrons and hydrogen having 1 electron like this. So 1 electron. So this carbon 8 electrons. This central atom having 8 electrons. Therefore, it follows the octet rule. But super octet means more than 8 electrons, but that molecule is stable. So I will discuss about superoctet molecule SF6. SF6 sulfur hexafluoride is an example for superoctet or expanded octet. So expanded octet means, so here sulfur, this is the structure of sulfur hexafluoride. This is the structure of sulfur hexafluoride. So each bond equal to 2 electrons, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here, SF6 how many electrons? 12 electrons. 12 electrons means 6 bonds, 12 electrons. Therefore, it is more than 8 electrons. Therefore, it is an example for superoctet molecule. Superoctet molecule. And we discuss about next one is odd number octet. Odd number, that is not considered odd number. Some molecules are having odd number, but they are stable. So which are odd number molecules we'll discuss about. So NO 1, 2, 3, 4, 5, 6, 1, 2 here, 3, 4, 5. So here, when you observe this structure, odd number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here 13 electrons. 11 electrons, sorry. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 electrons are there in this molecule. So this is 11 means odd number. We are considered only valence. We are not considered remaining electrons. So in this, how many electrons are there? 11 electrons, but NO molecule is exist. Nitric oxide is exist. Therefore, this is about incomplete octet. Incomplete octet means some molecules are having less than 8 electrons. Less than 8 electrons, but that molecules are stable. That molecules are stable. That molecules are also called as electron deficient molecule. Electron deficient molecule. Best example is BeCl2. So BeCl2, LiCl2, BCl3 and LiCl, BH2. I will give an example for this also. After that, superoctet. Superoctet means this is also called as expanded octet. So expanded octet means if when you observe the central atom, the central atom is bonded by more than 8 electrons, but the molecule is stable. Therefore, superoctet or expanded octet, best example is SF6, PCl5, SO4, so many molecules. After we give the list, just you have to remember, this is the best example for this. And odd number of octet, it is not considered as octet. So odd number molecules examples. But this is also one of the limitation. So, but it has not having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Like not 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 only. When observe. So odd number means 8 means even number. But they are also exist. They are stable. Best example is NO. So these are the limitations of some molecules. So we discuss about few molecules. So incomplete octet, superoctet, and odd number of electron molecules. This is about examples. After that, we will discuss about few examples for this incomplete octet and also superoctet and odd number electron molecules. Next one, electron deficient molecules. LiCl, BCl3, BeCl2. After that, LiCl, BCl3, next one BCl3, BeCl2, BH2. These all are examples for the electron deficient molecule. So LiCl also, LiCl, BCl3, BCl3, when you observe the structure BCl3, boron having 3 electrons and it can share with the 1, 2, 3, 4, 5, 6, 7 and one more 1, 2, 3, 4, 5, 6, 7 and chlorine 1, 2, 3, 4, 5, 6, 7. So here, so it can share one electron is 1, 2, 3, 4, 5, 6 only. So 2 electrons are least, 2 electrons are less in BCl3. So like these electron deficient molecules are so many molecules are there, but we discuss about these molecules are LiCl, BCl3, BeCl2, BH2, beryllium hydride, boron trichloride, lithium chloride, beryllium dichloride. So these are examples for the electron deficient molecule or incomplete octet molecule. Incomplete octet molecule. So after that, so expanded octet molecules. Expanded octet molecules. I will give few examples for this. So in maximum compounds, sulfur is existed expanded octet rule. Super octet molecule. Super octet molecules. H2SO4 is also best example. H2SO4. So a H2SO4 structure is like this. So here, this is the structure of H2SO4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this much of electrons around the not 8 electrons. Okay, more than 8. More than 8 electrons in case of sulfuric acid. But in some molecules it can follow the octet rule also. Sulfur dichloride, SCl2. So in SCl2, sulfur follow the octet rule. So here, this is. So here 1, 2, 3, 4, 5, 6, 7, 8. So it is octet rule. It's not obey the octet rule. Here follow the octet rule. Here not obey the octet rule. Is not here. Sulfur is not obey the octet rule. Sometimes it obey the rule. Sometimes it avoid the rule. So therefore, sulfur maximum compounds in expanded octet rule only follow. So after that, some more examples are there. PCl5, IF7, PF5. So I will give an example, more example for this. PF5, phosphorus 1, 2, 3, 4, 5, 10 electrons. PF 1, 3, 5, 5 fluorines, therefore 10 electrons. 10 electrons greater than 8. So IF7 is also example for the super octet IF7. Next PCl5 is also phosphorus pentafluoride is also an example for this IF7. So these are the super octet molecules. PF5, SF6. Next one, odd number electrons. Example I will give. Odd number, one more example. NO2. Nitrogen dioxide. So 1, 2, 3, 4. One more electron here. So this NO2 is also an example for the nitrogen dioxide. Is also example for the odd number of electrons molecule. So maximum molecules are follow the octet rules. So methane. Some more examples: methane, ethane. H2O, next one CO2, for example CO2. CO2 linear structure, is it octet or incomplete octet? Some examples are given. CO2. So we'll observe the structure of CO2 like this. 1, 2, 1, 2, 3, 4. Here also 4. Therefore, each molecule will follow the octet rule. Each element. Therefore, it obeys the octet rule. It obeys the octet rule. So, NO is not obey the octet rule. Once you observe the difference between which molecule is an example for the limitations of octet rule means they will give the molecules. For example, NH3. NH3 is obey the octet rule or do not obey the octet rule. So, I will draw the structure NH3, NH3 here. So, here one lone pair. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, 8 electrons, it obeys the octet rule. It obeys the octet rule. For example, H2O. H2O molecule is obeys the octet rule or not obeys the octet rule. So once you write the formula, then you can identify that one H2O. So here H 2 bonds here, 2 lone pairs. Therefore 1, 2, 3, 4, 5, 6, 7, 8. Therefore it is also oxygen, H2O molecule, oxygen central atom obeys the octet rule. For example, ethane. Ethane obeys the, carbon obeys the octet rule or not? Ethane. So this is the structure of ethane. So each carbon atom having 8 electrons. Therefore, it obeys the octet rule. So this is about limitations of octet rule. So sulfur in maximum compounds it does not obey the octet rule, but few compounds it obeys the octet rule. Therefore, this is about octet rule. Limitations of octet rule. So limitations of octet rule, we have 3 types: odd number of electrons, incomplete octet, super octet. Super octet we have already taken so many examples. For odd number of electron, nitrogen dioxide, nitric oxides are the example for the limitations of octet rule.